Welcome to the second part of the recap. In this lesson, we would sum up what we have learned till now from the coding point of view. To write a job, we just need to design and code three classes. First, the map class, second, the reduce class, and the third, the driver class. If you understand the objective behind these classes, the code would be relatively simple to understand. Let us first start with the objective of map. Simply, its function is to break the input record in key and value pairs. Objective of the reducer class is to process each key and its associated values to produce the ultimate result. Last is the driver class. As you know, Hadoop takes care of distributing the map code and the reduce code on the network. Programmer communicates to Hadoop what are the input files, what is the output directory, which class is the map class, and which class is the reduce class, and so on using this driver class. So all this information which is related to the execution of the job is communicated by the driver class. This is the fundamental structure, and if you remember this, the code is a simple Java code which should not be very difficult to understand. Let us look at the code. Let us start with map class. Now if you are a Java expert, this would be elementary for you. This lesson is specifically designed for someone relatively new to Java. Every map class inherits mapper class. Mapper class is specifically designed for Hadoop. When we inherit this class, we override the map function which has all the map logic. The fundamental idea is that Hadoop would already know where the user-defined map logic exists, and to call it, it just needs to call the map function. It helps Hadoop to distribute and execute the map tasks in distributed manner. Then the map logic is designed to handle different types of Hadoop data types, which we would study in the next segment. So the first pair specifies input key value data types, and the second pair specifies the output key value data types. These are termed in Java as type parameters, and here we would see only Hadoop specific data types. As you can see, we have put in a few variables here which would be required for the map logic. We declared this final and static so that it is not created again with every call to map function. Then the map function has three parameters: input key, value, and context. So here the data types of key and value should match with above defined type parameters. Context is a parameter in which we write the output key and value pair. After writing into context, Hadoop takes care of sorting, partitioning, and sending it across to the correct reducer machine. The return value of a map function is always void. As well, it throws IO exception and interrupt exception. These are necessary as they are defined in mapper class, and so inherited class gets these exceptions carried over from the parent class. These exceptions are just to handle the unexpected scenarios that can occur during the IO operation, or in case if the task is interrupted because of some reason. Then comes the logic, which is simply coded in core Java. There is nothing special to mention here, but just that there is this logic to break the input record line into keys and value pairs and write it to context object. Now the data types of the arguments passed in context.write method should match the type parameters mentioned above. This is it. This is the fundamental map structure. So in short, you just need to change the type parameters and the type of arguments and change the map logic, which should end with context.write method. And that's it. The rest of the structure would always be repeated. Yes, of course, as we move to advanced programming, we would see a few more functions, but the main theme would remain the same. At the beginning, just think map's function is to take the input record and break it into a set of keys and values, and that's it. Then let's look at the reducer. Word count reducer class would inherit the reducer class, and the reason is the same. This gives Hadoop ease to find and execute the user-defined reduce logic. Like the mapper class, reducer class as well has four type parameters. First to specify the input key and value data types, and the last to specify the output key and value data types. Then is the reduce method, which takes argument as keys and list of values, and context, which is used to write the ultimate result. The data types should match the above mentioned type parameters. Reduce function also returns void just like the map function. The idea is to write in the context.write method. Then comes the throws exception line, which is present for the graceful termination of the code in case of an error. Then comes the reduce logic. This for loop would be a common factor across the solutions. We would iterate through all the values of the keys in almost all the solutions. Then through the context.write method, we would pass the key and value, which ultimately is passed to Hadoop, and Hadoop in turn writes in the output directory which we have specified while running the program. So always in any reducer, you would see the same structure. Lastly, we look at the driver class. Remember, the whole and sole objective of the driver class is to tell Hadoop where is the map class, where is the reducer class, and the input and the output and the way to execute the job. All this is done by setting up the job object, and that is all we would see in the driver class. We extend the configured and implement tool interface, which helps our driver class to handle the parameters passed to a program at the runtime. At this point of time, I would request you to go through all the lessons of this section one more time if you haven't already gone through it. Map, reduce and combiners are absolutely new topics and requires new way of thinking, and it takes a little time to build understanding about them. One more iteration of the material would help you understand it in more depth. At the end, I would give you a little quiz. Here we have reused reducer as combiner again, but it is always to be remembered that the function of the reducer is different than the function of the combiner. Idea of the combiner is to reduce the map output, while reducer's main objective is to look at all the values associated with a key collectively to produce the output result. So my question is that here in the reducer class, if I would have changed this line and instead of that return sum plus equal to 1, that is, I would have incremented sum with 1, would this logic fit in the combiner as well? My second question is, would writing reducer like this would have left any scope of combiners? If yes, what kind of a combiner we would have used? Please give a think over this and contact me in case if you are confused.